So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on photocell characteristics apparatus. So in this experiment we are going to study the IV characteristics of photocell and also how the current is going to depend on the distance between the source and the photocell. So to perform this experiment we require the photocell characteristics trainer apparatus. So within this kit we have the voltmeter, ammeter and the load resistance. Here is the knob to operate the lamp. We can control the lamp with the help of this knob, and here are the patch cords, and this is the photocell which is having the positive and negative terminal. We have to connect this photocell to this apparatus, and here is the scale of 50 centimeter, that is half meter, and here is the light source. So we can vary the light source so that the distance we can increase or decrease, but this photocell is fixed in position, so we can only move the source near to the photocell or away from the photocell. Then we have to note down here the variation in the voltage and current. So first let us make the connections here with the help of patch cords. So first connect positive terminal of the photocell to the positive terminal of the photocell on this photocell apparatus, trainer apparatus. So negative terminal of the photocell to the negative terminal of the photocell on this apparatus. Okay, next we have to connect the voltmeter, positive terminal of the voltmeter to the positive terminal of the voltmeter, and negative terminal to the negative terminal of the voltmeter. So here we should connect the ammeter, positive terminal to the positive terminal and negative terminal to the negative terminal of the microammeter. So here first you can observe the range of the voltage and current. It is millivolt and this is microampere, and here is the power supply of 230 volt or the 15 hertz, and here is the load resistance. It starts from 1 to 10 k ohms, or you can see the multiplier here. So to start the experiment, first we should switch on the light source. Once the light falls on this photocell, there is a variation in the voltage and current, and we have to fix the load resistance. So there are different ways to perform this. So first let us switch on the source here. Source is on. When light falls on this photocell, we can observe here deflection in the microammeter. It is about nearly 25 microampere. So there is no deflection right now in the voltmeter. So if we decrease the distance, so we can note down the variation in the voltmeter and ammeter. So here I have reduced the distance between the photocell and the source. So you can observe here the distance is how much, nearly 20 centimeter. Okay. So the corresponding voltage and current you can note down here. Voltage is about 50 millivolt and current is about nearly 50 microampere or near to the 40 microampere. So as distance is going to reduce, there is a increase in the voltage and current. So if we decrease the distance further, we can observe rise in the voltmeter reading and ammeter reading. You can see voltage is near to 100 millivolt and the current is about 75 microampere. So as distance reduces, current is going to increase and the corresponding voltage also. As distance between the photocell and the source increases, current is going to reduce and also corresponding voltage. So we can keep the source at fixed distance, and if we apply the load resistance, right now it is at 1 into this multiplier. So load resistance in terms of ohm. So if I keep it at 2, you can see the deflection, but I am not varying the distance between the source and photocell. So if I will increase the load resistance, there is a decrease in the current and as well as voltage reading you can observe. Voltage is going to rise but current is going to decrease. So you can see the current is decreasing. So it is a maximum load resistance I have applied here. So the current has decreased for the same distance. So like that you can perform this experiment. So in this experiment you have to plot the two graphs. One is for current versus voltage and another graph is for the current versus the ratio of 1 by d square, that is inverse square law we can say. So two graphs you have to plot. So first you should note down the for IV characteristics for different distances current and voltage readings, and also you can vary the load resistance or keep the load resistance as fixed value and note down the voltage and current. And in the second way to note down the reading is keep the distance between source and the photocell fixed and vary the load resistance and note down the voltage and current reading.